Okay, hopefully you did that. So we're going to talk a little bit about behavior in robots. Behavior is anything your robot does, so it's really simple. Turning a motor on, moving forward, tracking a line, turning, all of that is robot behavior. There are 3 kinds of robot behavior. And I like to start at the bottom of my list, which is complex, big picture. Think about, I'm going to use a microscope here. So we're going to go big picture. I can see it. I want my robot to solve a maze. It's going to go forward, it's going to turn again, it's going to turn and park. And that's the maze. That's complex behavior. Lots of stuff goes into it. Break it down further, you get simple behaviors. Simple behaviors are things like move forward, turn left, move forward 10 seconds or 2.5 seconds or whatever. Turn left, go forward, that kind of thing. Those are simple behaviors. Basic behaviors are broken down again. Instead of go forward, which by the way doesn't work all that well with our cortexes, so you would instead say start motor and then wait 5 seconds, stop motor. That turns the motor on, waits 5 seconds. In that 5 seconds the motor is running, and so moving the robot forward, stop motor turns the motor off. That would be a basic command. So you're going from big picture, what do I want it to do? Smaller picture, what are the steps I have to do to get there? And then even smaller, what do I have to do to get that step done? So it's like writing an outline, basically. You're going from big picture to smaller picture to very, very small. And that's how that works. Complex behaviors always get broken down into simple, which are always broken down to basics. So I want my robot to run this little labyrinth. I need to identify the different behaviors. First thing, complex, go from the start to the goal. Complex. I want you to go down 20 feet down this hallway as fast as humanly possible. Those are complex behavior. Simple would be forward, turn left, forward, turn right again to go into the goal, right? Those would be the things I would actually type in my pseudocode. So complex behaviors really are like task descriptions. Pseudocode is really simple behaviors. Basic, start motor at 63, 2 seconds, stop motor, start motor, point turn left, stop motor. Those are what's actually code. And well, they're not code yet, but you're going to turn them into code. Those are the step-by-step of how you're actually going to get your robot to solve that maze or run that labyrinth. So, pseudocode is regular language that lets you plan what you're going to do. So you can see the example of pseudocode there on the right. Start motor, full speed, on for 3 seconds, stop the motor, off for 10 seconds, start motor, half speed for 3 seconds, stop motor, off for 2 seconds, reverse motor, half speed, on for 3 seconds, stop motor. Now that's a very specific set of pseudocode, but notice none of it's code. It's all written in regular English. I've even got like fractions in there for half speed. That's pseudocode. It's kind of code but not. That's why pseudo means kind of but not quite. So pseudo science means it's almost science but not quite. In this case it's almost code but not quite. It's an outline of what you plan to do, but it's not really code yet. Your lines of pseudocode should be listed in the same order that you're going to program in. That way, if you have to stop in the middle, which everybody I know does, they have to go get a drink, they get distracted by their partner, the class period ends and they have to go do something else and come back tomorrow. If you have written your pseudocode in order and then your code goes in order, it all works out and it's beautiful and you can figure out where you were. So, natural language. This is what we're going to be using to program, and when you set everything up, you'll see it's going to show up just like it is here on the left-hand side. You get your natural language library. So, it allows you to basically drag things from the library over into the code area, drop it, and then change the information. So, common commands stored in the function library. This saves a lot of time, because if I had to type things like start motor parenthesis and then put in the name of my motor, comma, speed, parenthesis, semicolon. It's really the semicolon that's going to screw you up because it screws up everybody. They forget the semicolon at the end of their line, and if you forget the semicolon, it stops reading it, and nothing below it counts for anything. So movement is one of the big things we look at. Start motor, stop motor are the two main movement pieces that we're going to drag. And you're just going to drag them over from the library, drop them, and then you're going to be typing in them. Special does odd stuff like turning on flashlights. We don't have any flashlights, but it could turn on LEDs and off LEDs and stuff like that. Untils are really interesting. This tells the robot to do something until something happens. And you can tell it what the thing is to do before the until, and then you can tell it what the action of the until is. And so if you look at the top one here, it says until bump, meaning whatever you're doing, just keep doing it until bump. And as soon as I hit that bump switch, then you do something else, and it bumps you into another set of code or gives you another command. So until bump waits until the switch is pressed and then let go. Until touch waits until the switch is pushed in. Oh, so this is the difference between a bump and a limit switch, and I get this a lot. People are like, it's a button. It's actually not a button because bumps actually read the press down and the release. The touches just register the initial boom touch. So that's the difference between until bump and until touch. You can use both. I've run into a lot of people who refuse to use until bump because they feel it screws up their code when things have to go really fast. And so they use until touch as their code because they feel the until bump takes too long because it's a press down and a release. And you can use an until bump with a bump switch or with a limit. But the point is that's the difference between a bump and a touch. Touch is automatic, poof, on. A bump is, now it's on. So it's like, it's a very small difference to most of us, and to most of us it's not going to matter. But to some people, when they're getting very technical with their code, it really can matter. Don't use until button press. If you're in my class, we don't have buttons, we have bumps and we have limits, and we do not use until button press. Doesn't matter how many times I say that. I always get like 5 kids who do it, and then I have to go back and say, that's not a button. And then they want to argue with me. So just flat out, no buttons. So waits. Waits are really fun because a wait basically tells the robot to do something for an amount of time. You could start the motor, wait 3 seconds, mean run the motor 3 seconds, and then when that 3 seconds is up, it's supposed to do something else. But you have to tell it what this something else is. Now, you can do waits in seconds, which would be wait time, or you can do waits in milliseconds. So 1,000 milliseconds is a second. So you can do a half a second, you can do a quarter of a second really easily. You could also do those with decimal points on the wait times, but I find that gets a little dicey. The milliseconds works really nice to have something wait 500 milliseconds and then start the next thing. For example, you can start your motor speed at 63, put in a wait for 3 seconds. Basically, that tells the Cortex to run that motor at half speed for 3 seconds. So let's take a look at this little piece of code. Write motor for 5 seconds. So first you got your start motor. Start write motor 63. That is saying start the write motor, which I have obviously named write motor, and run it at half speed. Wait 5.0 means wait 5 seconds, stop the motor. The task main up here at the top says I'm programming now. Everything below task main is code, unless you use your little comment thing and green it out. If you green it out, then it's not code anymore. So all the code goes between the open and closed curly brackets. Everything goes in order from top down. If you want to press the bump and then have something start, you have to have until bump before the something. I got so many people who put the bump somewhere weird and then they don't understand why it doesn't work. Your bump, whatever your first thing is, has to be the thing on top. So you drag and drop, you customize it, and then you run it. It's very simple. So once you get your code typed up, you're going to download it to your robot. In this case, with the new robot, see there's actually a little button with a little robot head. Very cute. Click it. It says download to robot. And it downloads to robot, and now your code is on that Cortex, and you can now run it. So at this point, I want you to try a couple of things. We're going to try turning on the right motor, running it for 5 seconds at half speed, which is 63, then turning it off. So your code is going to look very much, pretty much exactly, like the code that I have right here. Start motor, right motor, 63, wait 5 seconds, stop motor. Stop here and do that and show me that it's done so I can sign off on your thing saying, yes, you got that one to work, and then we'll move on to the next one.